this lesson and standard BF8, you're going to learn how to use transformations with quadratic functions. Each family of functions has a parent function, the most basic function in the family. The family of quadratic functions has the parent function f of x equals x squared. Here's an example, and to do this, you want to go to your TIA3 and click y equals, and you're going to see I have y1 equals x squared. So I'm going to go to graph, and that is what the parent function is supposed to look like. All quadratic functions can be thought of as transformations of this parent function. So you're going from there. You're transforming the function from the function I just showed you, f of x equals x squared. If you change the parent function by adding, subtracting, multiplying, or dividing by a constant, you transform the function and make a new function from the same family. Changing the equation of the function also changes the graph of the function. This change is called a transformation. Now, if you remember back in the 8th grade standards, we did transformations. You learned how to translate a function. That's just sliding it, or shape rather. You didn't do functions in 8th grade. You did translation, reflection, rotation, and dilation. Now we're going to use some of those today. The first one we're going to talk about is translation. Now, to translate an object in the 8th grade standards, you would slide the object. The size and shape of the object did not change. So dealing with translation with quadratics, all you are doing is shifting up or down, left or right of the parent function. So the function g of x equals x squared, that x squared is the parent function, and you're adding 5 to the parent function, and therefore moves the graph 5 units up from the parent function. So let's go back to our graphing calculator. Okay, there's my parent function, and I'm going to leave it just like that, and I'm going to add x squared plus 5. As you can tell, if you add a constant to the parent function, it slides up. If you add any constant to the x squared, you are going to slide it up. Now, if I add, what do you think happens when I subtract? So let's subtract 5. As you can tell, when you subtract, it slides down. And this is if you are subtracting or adding to the x squared. You're going up or down on the y-axis. Now, let's say we add a constant inside the parent function. So we're not adding to x squared. We are placing a constant inside the parentheses with the x. For example, x plus 3 squared. What happens there? So let's go back to our graphing calculator. And here's what's weird. It is the opposite. When you add 3 or you add a constant, the graph that goes left. Let's say I subtract 3. The graph goes right. That is the hardest thing to remember. But what you got to remember, it's going the opposite way. It is going the opposite way. Now, in your notes, you had described the function. X squared, that is the parent function. X squared plus 5, when you pop that in, up 5. X squared minus 8 goes down 8. X squared plus 10, up 10. Now let's go back to the graphing calculator and let's do one more. Let's do the x minus 8 squared. And before you pop that in, think about it. Which way are you going to go on the x-axis? Okay, there's our parent function. We subtract 8. When you do that, it slides to the right 8 times. So, this would go right 8. X plus 5 would be left 5. And then left 7. Again, this is for translation. Reflection. Now, I'm not going to read all this, but what I want you to remember is this. When you reflect a shape, when we did that in 8th grade, it is a mirror image. So reflection with functions is going to be a mirror image of the parent function. As you can tell, there's an example. G of x is a reflection of the other function. Now, let's go back to the graphing calculator. Leave x squared. But I want you to place this one in the graphing calculator. Okay, there's the original parabola, the parent function. As you can tell, when you multiply a negative to it, it flips over the x-axis. So x squared, the reflection over the x-axis of x squared is negative x squared. Okay, now go back to the graph calculator and I want you to put in 3x squared in y1 and then negative 3x squared in y2. Click graph. There's 3x squared and then there's negative 3x squared. As you can tell, they are reflections of one another. Now, I'm going to look at this one, and that's going to be the only example I'm going to do. I have x squared minus 2x minus 1, and I want to reflect it over the x-axis. To do that, what do you think we need to do? What I want you to do right now is think, how did I get from x squared to negative x squared? How did I get from 3x squared to negative 3x squared? If you guess, multiply the equation by negative 1, you got it right. So let's do that. Let's go x squared minus 2x minus 1. And I'm going to multiply that entire equation by negative 1. And I get negative x squared plus 2x plus 1. And this would be a reflection of this. Last transformation we're going to learn about is stretch and shrink. Translations and reflections do not change the size of the graph being transformed, but stretches and shrinks do. After a stretch or shrink, the new graph's wider or narrower than the original graph. Multiplying the output of a function by a constant stretches or shrinks the graph in the vertical direction. For example, if the constant is greater than 1, the graph of g is a vertical stretch, and if it's less than 1, it's going to be a shrink. Now, the weird thing is, you're going to call it a stretch and shrink, but I want you to look at what happens. So let's go to the next page, and go ahead and put x squared as your y1, the parent function. And then I want you to put in 8x squared. Now, before we hit go, before we graph it, go back and look at the notes again. What happens when the constant is greater than 1? It's a stretch, right? It should be a stretch. So let's go ahead and graph it. There is the parent function, but look at that. That doesn't look like a stretch, does it? Here is why it's called a stretch. Yes, it looks smaller than the parent function, but it's called a stretch because you're stretching it away from the x-axis. You're stretching it closer to the y-axis. That's why it's called a stretch. So if it's greater than 1, it is a stretch. Now let's go back. And I want you to put in 1/8. Erase y2. Put in parentheses 1/8, close parentheses, x squared. Okay, so I'm comparing 1/8 x squared to x squared. Hit graph. There's my parent function. Now look at that. You would think that's a stretch, but that's actually a shrink. A shrink is when it's less than 1 and it is being pulled towards the x-axis. It's being shrunk, per se, towards the x-axis. And this is called stretch or shrink transformation.